Alrighty, I promised this quick video on the two proofs from section 6.9 of geometry. So what I'm going to do is I'm going to just go through the proofs and you can follow along, check what you did, compare notes, and maybe you did a little bit different, but we should be looking for the same result here. So the first one we've got is number 10 in the notes. I think it's a little bit bigger. What we're going for here, it says use coordinate geometry to prove the following. And just to note, the coordinate proofs, they're not as formal as a formal written or two-column proof. We're not so much worried about the reasons, but we are trying to get to an end goal. And in this case, we have a given, which is that we have triangle ABC. And we know what A, B, and C are. So A is 0 to A. That means that the height would be 2A. B is negative 2A and 0. And C is 2A and 0. What we're trying to prove is that, this is what we're trying to prove, ABC is a right isosceles triangle. So if you look at the triangle, in order to do that, we got to find two things. We need to find first, and I'm going to say what we need to show that AB is congruent to AC, so the two legs are congruent to make an isosceles. And we want to find that this is a right angle right here. So the best way to prove that in my mind is to see what the two legs are, and if they're perpendicular, then it would be a 90-degree angle. So we're going to also try and figure out that AB is perpendicular to AC. So let's do that. We're going to use a couple of different formulas here. So first off, let's do the first part. Let's see that AB is congruent to AC. So if I'm looking for lengths, I'm looking for the distance formula. All right, so let's see what AB is. AB is equal to, using the distance formula, square root of x 2 minus y2 plus, or squared, plus, sorry, x2 minus x1 squared plus y2 minus y1 squared. So let's plug those in. We have x, we'll do, this one is the first one, so 0 minus negative 2a, and we'll square that, plus 2a minus 0 squared. That right there is going to get us to the square root of, let's simplify some things inside. So if this is a, two negatives together make a plus, and if we square 2a, that's 2a times 2a, which is 4a squared. And this would be 2a minus 0, which is 2a. So same thing. Plus 4a squared. And again, that would equal, if you add them up together, that'd be 8 total a squared inside of the square root sign. And I'm not gonna simplify that any further because we have to figure out the square root of 8, which would be 2 square roots of 2, I believe. And we don't need that. Let's just leave it as it is. It'd be 2 square roots of 2 times a, but let's just leave it like this right now. Now let's figure out what AC is and see if it'll get to the same thing. AC equals, so this time we're going to use A and C. So, square root of, we're going to go A to C, minus 2A squared, plus, we're going to go 2A minus 0 squared. That equals square root of, let's simplify some things, Negative 2a times negative 2a would be 4a squared plus 2a minus 0 is, again, 2a squared would be 4a squared. That means we'd have a total of 8a squared underneath the square root sign. Alright, so that means that AB is congruent to AC because their lengths are the same. So now we've got this part. Now we're going to use in green here, we're going to try and figure out if AB is perpendicular to AC. So you might think we'll use the slope formula. Let's look at their slopes to find if they are perpendicular or not. That's why you need to know the slope formula and things about it. Alright, slope formula, slope of AB. y2 minus y1. So it doesn't really matter which one is the first point and the second point. So we'll do 2a minus 0 over x2, which is 0, minus negative 2a. Which also that becomes a plus. So then we have 2a over 2a, which equals 1. So let's check the slope of AC. So we've got the y's, so 2a minus 0 again. Or hold on. Yeah. 2a minus 0 over 0 minus 2a, which would equal 2a over negative 2a, which would be a negative 1. Since those slopes are opposite and reciprocal, we can say that AB is perpendicular to AC, which is that second thing we want to prove here. Now that we proved those, we can close it by saying, therefore, ABC is a right isosceles triangle. All right, and that's what we need to prove, so we are done. All right, so there's all the work if you want to check it over and pause it. If not, I'm going to go on to the next proof. The next proof is given, I'm trying to prove that the measure of the segment that joins the vertex of the right angle in a right triangle to the midpoint of the hypotenuse is 1/2 measure of the hypotenuse. So in other words, we're given triangle ABC, and we know that A is 0, 0, so that's at the origin. B is 0 and 2b. That means that that height here would be 2b. And C is 2c and 0. Oops, 2c and 0. We're trying to prove that we'll say this is D here. AD, is 1/2 of the hypotenuse, which is BC. Now I looked at that and I see that if this is 1/2 of this whole thing, and this is the midpoint D, then this should also be congruent to the 2 parts. So that's what I'm going to prove. I'm going to show that those three are congruent, because I think that'll be easier once I find the point D anyway. So, what I'm going to do is I'm going to minimize this a little bit so I can have a little bit more room. And not sure how that happened. that's what we're trying to prove up there. Now, first of all, we got to figure out what D is. And that's going to use the formula, the midpoint formula, since D is the midpoint of BC. So we'll use the midpoint formula. All right, the midpoint formula is pretty much finding the average of the x's and the y's. So the midpoint of BC would be, let's see, the average of the x's would be 0 plus 2c divided by 2. And the y's would be 2b plus 0 divided by 2, which equals c and b when you divide it out. So it would be point C, B. All right, so now we've got all the points that we need to do. Let's find some distances then. So we'll find the distance formula. We'll use the distance formula. Formula. All right, so let's find AD first of all. AD equals square root of C minus 0 squared. It's nice using the origin. Plus B minus 0 squared, which of course equals C squared, or the square root of C squared plus B squared. And we're going to leave it at that. Now let's find BD. Square root of 0 minus C squared plus 2B minus B squared. So inside of here, that's going to be negative C squared. And if you multiply the negative by itself, it cancels out. So then you just have C squared. And here, 2B minus 1B would be B, so plus B squared. And then lastly, we're going to do DC. So this is, I'm going to add this over here. So DC, let's take the square root of C minus 2C squared plus B minus 0 squared. That would be equal to, let's see, that would be negative C, negative 1C, and you square that would be C squared plus B minus 0 is B. Oh yeah, we have the square sign up here, so B squared. So if you look at it, those are all congruent. And if you want to combine B to do what BC would be, this would be BC equals 2 times the square root of C squared plus B squared. Whereas AD is just one of those, so that's C squared plus B squared. And that proves what we're trying to prove. That AD is half of BC. So, therefore, we can say that AD truly is equal to 1/2 of BC, or that what we wanted to say is that the segment that joins the vertex of the right angle in a right triangle to the midpoint of the hypotenuse is 1/2 the measure of the hypotenuse. And that would be how you go about proving it. I hope this video helped. Have a good one.